Welcome again, viewers. So in this video lecture we are going to see the basic laws of engineering mechanics. So what are the different laws that govern the fundamentals of engineering mechanics? We'll see in this video. So these are the very important basic terminologies to be understood before getting into the basic concepts and the related problems of engineering mechanics. We must understand the meaning of each and every term used for the knowledge about engineering mechanics. So we'll start with a few terminologies here. We often come across a number of terminologies in the subsequent video lectures. So one should be able to identify the literal meaning of each and every terminology used in the subject. So rigid body. So the relative movement between its parts are negligible, which means that a rigid body is always a body which has a tightly packed components, which is a solid body, and dynamics deals with the rigid body in motion. Length is applied in the linear dimension of a straight line or a curved line. Area is the two-dimensional size of shape or surface. Volume can be taken as the three-dimensional size of the space occupied by the substance. And the definition for force, the simplest definition for force is that the action of one body on another, whether it is a push or a pull force. So if a force is exerted over the component in the push manner or pull manner, it can be called as a force. Then mass, the amount of matter contained in a body is called mass. So there is a distinct difference between force and mass. The unit for force is Newton and the unit for mass is kilogram. And weight, the force with which a body is attracted towards the center of gravity of the earth is called weight. Particle, a body of negligible dimension. So we have seen the basic terminologies in the previous slide. Now we are going to see the very important basic laws that govern the engineering mechanics applications. We'll start with the triangular law of vectors. So triangular law of vectors, it gives the explanation about the angle of the force and the magnitude of the force when comparing to the two forces acting over a system. So already two forces are there and we are going to get the third force, which is going to be the equivalent of the effects of the first two forces. So totally we have three forces, and when the three forces are combined together, graphically it becomes a triangle. So this is stated by the triangle law of vectors. First let us see the statement of triangular law of vectors. It states that if two vectors are represented as adjacent sides of a triangle, then the third side taken in the opposite order is the result of the two. This is called triangular law of vectors. This law is used to find the resultant of two vectors, which gives both magnitude and direction. To put it in a simple way, you have to make a triangle out of the three forces acting over the system. And you have to take the two known forces one by one. It has to be attached together with the same angle, with the same angles they are acting over the given system, and you have to connect the end of the first part, that is the starting point of the first force and the ending point of the second force, by means of a straight line. Then this would become the triangle. Here comes the example for the triangle of forces. So to find the magnitude and direction of the resultant force, we have to follow the triangle law of forces. So I have already given the definition about triangular law of forces in the previous slide, which states that in a given system, if the force A is acting with a certain magnitude, say for example 100 Newton or 10 Newton, it can be of any kind of magnitude. It has to be drawn with a corresponding scale. Say for example, the force A moving horizontally in the right hand side with a certain magnitude, say for example 100 Newton, is drawn this way. And over the same system, another force is acting, which makes an angle of theta from the horizontal in the counterclockwise direction. So the starting point of the second force, that is the force B, has to be at the end point of the first force A. Then with the same angle with respect to the horizontal, we have to make a line with the corresponding magnitude. So this can be a magnitude, this can be a same magnitude or different magnitude. Say for example, the magnitude of B is Y, provided the magnitude of A is X. Then we have to find the resultant of these two forces, which means that the resultant meaning is very simple, that the effects produced by the two forces separately will be the similar or will be the same by the resultant of these two forces. Got it? So theta is the angle between A and B forces, whereas phi is the angle between C and A. That is the angle between the resultant and the first force, or the angle between the resultant to the horizontal force is phi. There is going to be a formula given here which says that the force C, magnitude of C, is equal to the whole square root of a square plus b square plus 2ab cos theta. If you substitute the values of a, b and the angle theta in the given formula, we can be able to get the magnitude of the force C. Similarly, to find the angle phi between the resultant and the first force A, we have another formula which is phi is equal to tan inverse of b sin theta divided by a plus b sin cos theta. So C makes an angle phi with the vector A. So using these two formulae, we can be able to get the magnitude and direction of the resultant force acting over the system, which has only two forces.